Good morning, everybody. My name is Vishnu Dutt, and I have Rohit and Punish with me. And we are into the session number 7th of Cisco Certified Network Associate course. And actually, it is pretty interesting that I haven't discussed the course content with you till now, right? But that is fine because we are going great. We are doing good in terms of covering the syllabus also. And today, what we are going to talk about is to solve a problem. If you attended yesterday class, then we were talking about a serious problem in the layer 2 network, right? If we have a particular layer 2 network, then we all know that if these switches are connected like this way, then there is a problem, and the problem is known as the loop issue, right? We could see that the ARP messages were flowing like what we can say, right? From one place to other place or one switch to other switch and then coming back. And it was definitely not a good thing, right? So what we are going to do is we now understand the problem. We will try to resolve this problem using some protocol, which is known as the spanning tree protocol. So what we are going to discuss, what we are discussing right now is the agenda of today's session. So we will start from spanning tree protocol, and you should understand that why we came across spanning tree protocol, why there is a need to develop this protocol, because we now understand the problem in layer 2 networks. It is as simple as that, right? So there are some nitty-gritties like port rules, forward delay timers, per-VLAN spanning tree, rapid spanning tree. These are the byproduct of a spanning tree protocol. Once we understand what is spanning tree protocol and how does it work, how does it avoid the loop, then we will be caring about these concepts. So do not worry about them, right? And today, in today's class, we are going to discuss another important concept, which is ether channel. We also call it as a port channel. And this is one of the cool thing, right? What is that? So if I have two switches, right? Suppose I have two switches. On a pretty high level, if I give you an introduction about the ether channel, if I have these two switches, switch number 1, switch number 2, and if I connect these two interfaces, you know that although the only two interfaces are connected, but I can see a loop here. If this is a loop, then it's a problem, right? And if you see this, you are going to say that just stop, just kill one of the link. Do not create this topology. Just have only one link. But sometimes we need more than one link between two switches, right? Without any routing loop also. If that is the case, then we are going to use ether channel. How and why behind it, do not worry about it. We will be talking about it, right? When we are done with these concepts, maybe we can start a session on whatever we have learned, like spanning tree protocol, like ether channel, right? And in the meantime, we can think that we are lost now, right? We might think that where are we with respect to our current learning? Do not worry. We are here for you. We won't be letting you lost, right? And if time permits, I'm not sure about it, we are going to start routing basics, right? And a routing protocol introduction also, which is OSPF. At the first place, of course, if we are bringing OSPF, we should be understanding why behind it, why there is a need of OSPF. But you should be concentrating on at least one thing, right? We have been talking about last 2-3 days a few concepts, but believe me, whatever we are talking about now, we are just improving the efficiency of the system, right? Because we have seen, we now know that how two computers are going to talk when they are pretty nearby in a LAN, or how they can communicate when they are really far away, right? And now we are just increasing the efficiency of it. Why we are bringing today's topic? Because we do not want loop in layer 2 network. It is as simple as that, right? Having said that, Let's move to our first board where we are going to talk about this protocol, spanning tree protocol. If I remind you, the goal is just simple. We understood that there are three switches. I will draw it here also. This is my switch number 3, this is my switch number 1, and this is my switch number 2, right? And they are connected like this. You all agreed yesterday that Mr. Vishnu, you are right. You're absolutely right that if some host from here actually send a message on, if it is a broadcast message, it should be going here, and then coming back to this, right? And this switch is going to send it again, forming the complete loop. And if there is a loop, we need to shut down a particular link, right? Maybe that link between this link, number 1, number 2, number 3. What is that link, right? But it is for sure that at least one link should go down. Otherwise, we will be seeing this loop, right? So, number first thing, as we discussed yesterday, which link that should be. By accidentally, we do not want that you shut down the link, which is a very high capacity link. What is the meaning of high capacity? The meaning of high capacity is, of course, if I have a link which is having 1 Gbps, right? 1 gigabits per second strength, it means that I can send 1 gigabits of data per second on this link, right? And suppose if I have another link, maybe the green link, and this can send only 10 Mbps of data. This is million bits. Of course, the Mbps is smaller than this one. So this link capacity of sending data is less as compared to this one. And I do not want that by accident, I will be shutting down the link which are of high capacity, right? So I need to involve this factor too, that which link is of high capacity and which link is of low capacity, right? It should not be like that. See, I can see that there is a loop between switch 1, switch 2, and switch 3. I can straight away see that, right? But which link to block, this should be my responsibility. And I should not be shutting down the link, which is actually high capacity link, right? And one more thing, now you can see the loop. You are human, I am human. I can see, I can detect the loop, right? But how to make sure that these switches are doing the job, because you cannot be present in every network, right? You won't be there in every network to detect these loops. And that is why we are developing this software, right? There is a protocol which runs between switch 3, switch 1, and switch 2. Every switch understand the rules of that protocol. The protocol name is spanning tree protocol, right? And every switch understand that code, whatever is written into the switch, depending on spanning tree protocol. And these switches are going to work together with each other to know which link we are going to block. So if I give you a clear idea, you all should know that what we are going to do here, right? We will be doing the side-by-side comparison. Believe me, on the right-hand side, whatever I am drawing with a yellow pen, right? This is going to be the informal discussion. On the left-hand side, whatever we are going to write, it is going to be the formal discussion with respect to spanning tree protocol. But we all know that if we understand the problem, if we can solve the problem, there is no doubt that we can write the code of spanning tree protocol. But here, if you can see, what do we want to do? We actually want to create, out of this topology, we should be creating a topology which should be looking like this. If we have decided to block the link between switch 1 and switch 2, the final topology should be looking like this, which is actually loop free, physical loop free, right? How to do that? At the first thing, when we start doing all these calculations, we should be starting from a particular point, right? Again, I want to go on the right hand side of this board, right, to make you understand. So try to understand, this problem is just like this, that we have three different places, right? This is A, this is B, this is C, and these places are connected like this. Distance between A and B is maybe 20 kilometers. Here also this distance is maybe 20 kilometers, and here the B and C distance is 5 kilometers, right? So you all know that if you want to go from A to B, the shortest path is going to be 20 kilometers for sure, right? Although there are two paths to reach to C here, you can go from here and here, but that is going to make it 25 kilometers, right? Similarly, you can go to B also from here to here. That is going to make it 25 kilometers. But all you know that yes, the 20 kilometers is the shortest distance between A and B and A and C, right? So shortest distance wise, A can reach to B, A can reach to C. But here is my problem, right? I want shortest distance as well as loop-free topology. I do not want that this physical connectivity has any loop, right? So if you see a tree structure, tree doesn't contain any loop, right? Maybe trees start with a root, right? And then basically its branches goes like this, and then basically there are several other branches, right? So basically in tree structure, we do not see the loop. And on the top of it, what we are going to do is we are going to find the shortest path too, right? So if you are from engineering background, which you are, you must have heard these terms, trees, graphs, and everything, right? If you do not, then it is perfectly fine. That is okay, right? But you should understand that what we are trying to achieve. So first thing first, if we want to make a tree-like structure which doesn't have or which doesn't have this loop, we need to begin with some starting point, right? And here maybe I can choose the starting point as A, B, or C. Anything can be your reference point, right? Where exactly we want to begin. Here I can see A, and A can reach to B or 20 kilometers, and A can reach to C over 20 kilometers. But yes, now if I want to shut down this road, then B and C distance, minimum distance is going to be 40 kilometers. Why? Because we do not want the loop into the system, right? But where to start? Where to begin? A, B, or C? I could have started from C also, right? And could have come into the same conclusion too. Interesting. But here, you are the human. You can start from anywhere, but we need to inform these switches where to start, where to start building this topology from, right? And there, and that is why there is an election of a switch first. The first thing first, we are going to elect a switch, which is going to be my root switch, right? One interesting thing, if you see here, that if I say bridge instead of switch, then try to understand when we were developing these protocol, right? When the network engineers developing these protocols, there was no thing called switch, right? At that point of time, we were evolving. So there was only hub, right, which was sending every packet to everybody, right? Then we came over the bridge, and when we were at the bridge, we were developing this protocol. So all the terminology here, including whatever is included in spanning tree, is all about bridge. So if I say switch or bridge, just try to understand both are same thing, right? So what we are going to do here, first we are starting from a place where exactly we can start. We can start from any switch, switch 3, switch 1, switch 2. But this is a computer system. You need to start at least, you need to calculate where we are going to start. So here is the thing, how we are going to say that who is the root bridge or root switch. So when you switched on all these switches, right, everybody is saying, I am the root, right? Because it doesn't have any idea about who is present on this topology. They just say, I am the root. This also says, I am the root, right? And this switch 2 is also saying, I am root. It is as simple as that. or they are presuming themselves as the root. They are saying the topology calculations should start from me. Which link should be blocking, or which is the link which we are going to block or shut down? It should be started from me because I am the root. Don't you think that it's not a pretty efficient way, right? It means that these switches, switch number 1 and switch number 3, or switch number 1 or switch number 2, or switch number 2 or switch number 3 should talk to each other, right? And that is why they talk to each other with a special mechanism or with the special messages which we known as bridge protocol data units. Interesting. So when switch 3 comes up, it is going to generate a message which is known as BPDU, right? And in this BPDU, it says that I am the root. Interestingly, switch 1, because it also understands spanning tree protocol, it is also going to generate a BPDU. It will be saying, I am the root. Now switch 1 and switch 3 are talking, right? Because they are receiving messages of each other. Switch 3 is getting the message of switch 1. Switch 1 is getting the message of switch 3. But interestingly, both are saying that we are the root. On what basis the root is going to be decided, elected, right? So root is elected on the basis of MAC address. What is the meaning of MAC address? Every switch in this topology is going to have a MAC address, right? This is not the MAC address of this host, no, right? So suppose switch 3 is having the MAC address of, right? MAC address of maybe say 10, okay, dot A dot A. Okay, let's choose something else. Suppose this is E dot E dot E. The MAC address of this guy is, suppose this one is ABC. I need to take A, B, C, D, E, right? I do not want to take F. Okay, so let's take this one is C dot C dot C, but I want to make it bigger one. So, okay, sorry for that. Sorry for all these calculations. This is E dot E dot E, right? This should be D dot D dot D, and this is my C dot C dot C. You will come to know later that why I am doing this. So every switch, suppose for now, it is having a MAC address, right? And the spanning tree protocol rule book says, or the protocol says, because protocol is nothing but the rules, right? And the rules which are designed by by the developer of spanning tree protocol say that anyhow we need to select a root to start with, right? And we are selecting a root on the basis of MAC address. Whoever is having the largest MAC address, it's going to be the, and here is my confusion. Rohit, can you please confirm? In spanning tree, it should be the smallest one or the largest one? The MAC address? I would say it's the largest one, right?
It's smallest one. Smallest one.
It is smallest one. Okay, this is my confusion, right? So if that is the case, then I need to again change this numbering, right? Because I want my switch tree to be the best switch, right? So this is going to be C dot C dot C. Extremely sorry for this. This is D dot D dot D, and this is E dot E dot E. I always have confusion, right? Because once you get into this networking, there are so many tiebreakers going to be. Sometime you are going to choose on the basis of higher number. Sometime you are going to choose on the basis of the lower number, right? So let's see. Here, the spanning tree protocol rulebook says that whoever is having the smallest MAC address, that is going to be the root bridge. It is as simple as that. So switch 3 is going to say that I am the root. Switch 1 is going to say I am the root. But now switch 1 understand, based on the rules, that although I am advertising that I am the root, but I just received a BPDU or Bridge Protocol Data Unit, which is saying its MAC address is CCC, right? Because in BPDU, what you guys are including in BPDUs, we are including actually the MAC address, right? And also here in this BPDU MAC address is going, so switch 1 and switch 3 will come to the conclusion that switch 3 is actually the root. Similarly, switch 3 is going to advertise the BPDU here, switch 3 is going to advertise the BPDU from here to here. Interesting, right? Then switch 2 comes to know that, of course, switch 3 is going to be the BPDU because it's having the smaller MAC address, right? Now, switch 1, when it's advertised, I am the root here, switch 2 is advertising, I am the root here, right? Everybody, switch 1 now understand that it is no longer a root. So it is saying in this BPDU that, look, Mr. Switch 2, although I am advertising the BPDU, but I have find somebody else who is the root, which is the switch tree, and it is going to write the MAC address of switch tree here, that this guy is the root. Although my MAC address is d.d.d, but c.c.c is the root, and this guy has to convince on that, right? Because c.c.c is the lowest MAC address. It is as simple as that. So after some time, when this BPDU got exchanged, everybody is going to have the same perception. Everybody is going to say that yes, switch 3 is the root. It is as simple as that, right? Doesn't matter depending on what lower number, higher number, you can always read it, right? But yes, right now you guys are telling me it's a smaller number. It is the smaller number, means spanning tree protocol. Whoever is going to have the lowest or the best MAC address, it is going to be elected as the root, right? Although there are some other rules too, right? Because, for example, MAC address is all hard coded in this switch, right? So you should not let the system to choose, right? What if you want to choose that switch 2 is going to be my root switch, because root switch placement is very, very interesting, right? We can see it, or you are going to see it when you are going to deploy the real world network, that where to place the root switch. It is going to be very, very important, right? So there must be some mechanism through which you can select this root bridge. It should not be on the basis of MAC address. Why? Because MAC address has been hard coded, and if that is the case, then the MAC address will decide any switch as the root who is having the who is happen to be the lowest MAC address. So there is a number too, right? And by default, this number is actually 128, which is attached with this MAC address, right? So by default, this number is 128. So every decision is going to happen on the basis of MAC, right? But you can change this number. You can make this number smaller. For example, and we call this as a priority. So basically, on the basis of what you are going to decide the root, you are going to decide the root on the basis of priority value plus MAC address. If priority value is the same, then basically it is going to decide on the basis of MAC, and by default the priority value is 128. So it is always be decided on the basis of this MAC value, right? What you need to do if you want to choose E.E.E as your, or C.C.C, or maybe, right? Maybe switch 2, you want to decide to become the root. What you are going to do? You know that its MAC address is going to be E.E.E for sure, right? But you can change priority. There are so many commands to change the priority value, right? So if you change this priority value from 128 to maybe 1, of course, 1 is less than other priorities values, which is configured by default 128 here. So instead of checking the MAC address, it will be decided on the basis of priority value. That priority value is 1 here, and my switch to is going to be root. Guys, do not get confused. We are just having an election here, that from where to start, calculating the topology, which is very, very simple. How you are electing? On the basis of MAC address first, if the priority value is same, If the priority value is not same, then decide on the basis of the priority value. It is as simple as that. Interesting, right? Now, let's talk about, so we are done. We are done with the first step. Here I am saying that the switch 3 will be my root, and is the reason is because it is having the lowest MAC address and because the priority was same, right? The second point which I would like to discuss is that we need to select, right? We need to select a port on the switch which is pretty near to the root bridge, right? What is the meaning? The meaning is straightforward once again. What we are going to do, guys, here, we are having three different switches, 1, 2, and 3 here, right? We have decided this is my root. So I am deciding that, as I mentioned, that I need to choose a best link also. So on every switch, what I'm deciding is what is the best way to reach to root. What is the best way to reach to root, right? This is what I wanted to know. It is as simple as that, right? And that is what I will be deciding on and every root bridge. Now what I'm going to find is I'm going to find a port which is most closest to it. So this is going to be my root bridge or root switch. We have just elected. Now I'm going to find a particular port which is closer to root bridge. Now, what is the definition of this, right? So suppose I am just writing the cost of these link also. What is the meaning of the cost? The lower the cost, the lower the distance, the greater the link is, right? This is 10. Suppose this is 10 and say this is 5, say, right? Interesting. Or maybe you can have this also 10, but let's take this example, right? So if you calculate how switch 1 can reach to switch 3 in shortest distance, that there are two paths, right? One is from directly via this 10. It is going to be 10. It is as simple as that. The other one is via this guy, right? This is going to be 5 plus 10. It is as simple as that. If that is the case, then which port is closer to switch 3? Of course, 0/1 is going to be closer for switch 3, right? Because the cost to reach switch 3 from here is going to be 10, and from there it is going to be 10 plus 5, 15, right? This is the port we need to decide on every switch, and we call this port as the root port. So we need to find the root port. Why root port? Because it is having the lowest distance to reach to the root. It is as simple as that. Interesting, right? So we are finding the root port on every non-root bridge, right? This was my root bridge. I'm not concerned about it because I want to know from where I'm going to get towards the switch tree in a least cost manner. It is going to be 0/1. It is as simple as that, right? Similarly, here also, this is going to be my root port. This is going to be my root port. It is as simple as that, right? And of course, 0/1 is not going to be root port of the for the switch 2. And the reason is because the distance is going to be 15. But how we are going to calculate this distance? Because right now you can see that how computers are going to be knowing about it, right? So by the way, guys, in the initial election, right? Every switch is sending the BPDU, but once it is done, right? Only the BPDU which can generate these, only the switch which can generate this BPDU is going to be the root. It is as simple as that, right? So switch 3 is going to send this information towards this guy. It is saying that I am generating the BPDU, I am the root. And what this guy is going to do? 0/1 knows that on this interface the cost is 10, right? So this BPDU was generated by the root bridge. So of course, it will be sending it with the cost of 0. Why 0? Because it is generated by the switch, right? When it reaches here, switch 1 will add 10 to it. Why 10 to it? The reason is because the 10 is configured here, right? Because the link cost is 10. This way it comes to know that whatever the BPDU I am receiving from here, it is having 10 cost. It is as simple as that. Similarly, when the BPDU is advertised from here to here, it will be having 10 cost because when you receive it, you are going to add whatever you have configured here. So basically, you have 10 here. These switch 1 and switch 2 knows that they are 10 distance away or 10 cost away. And now, as I mentioned, that only root bridge is going to generate the BPDUs. The other bridges are going to just forward it by adding the cost. So switch 2 is going to add the cost of 10 and then forward it. It is as simple as that. When 0/2 receive it, it is going to say that it will be adding 5. So this way it will be seeing that the whatever I am receiving is actually having 10 plus 5 cost. And from here, right? And that is why switch 1 comes to know about through the BPDUs working that 0/2, if I go to 0/2 towards switch 3, it is going to give me more cost as compared to if I go straight. And how these switches are coming to know about it? Come to know about it? The reason is the bridge protocol data units which are generated by the root switch. And what these middle switches are doing, they are just adding the cost to it and forwarding it. It is as simple as that. Interesting, right? So you can straight away decide from now on, we are done with the two-step. The step number 1 was elect root bridge, which is going to be your switch 3. Step number 2 is elect root port, which is going to be here, this one, and here, this one. Why? Because I am saying that the cost is 10, 10, and 5. It is as simple as that. I'm spending time here, guys. Please pay close attention. This is requirement. This is required. Why? If you understand this problem, believe me, whatever the software defined networking solutions which are coming like ACI, SDXs, right? If you understand this, you can appreciate those. If you can understand this, that thing can be easy for you, right? These are the things which is missing in many of the network engineers. Everybody understand that a spanning tree protocol avoids loop, but how? We are talking here. It is not that difficult at all because at the end of the day, we have to just remove a link from here, right? But yes, just try to understand, try to see the beauty of these guys, right? That how they are coming across that the link should be shut down when the process is done, and the link is going to be the one that is having the smallest, that is having the what we can say uh, uh, that is having the worst link, you can say, right? So these number, from where these numbers are coming, if you have the more bandwidth, right? For example, if I give you that for 1 Gbps link, this is actually your this cost value. Okay, let's leave about the cost value for now. We will talking about it later. Now let's talk about the step number 3. The step number 3 is going to be here, where we are going to find a port which is designated port. And what is the meaning of designated port? The port which is sending the best BPDU on a segment. And here most of the people get confused. That I agree, Mr. Vishnu, that you are saying election of root, that is perfectly fine. You are saying we are finding the root port which is closer to the root switch. We are fine. But what is this designated port? Let me explain to you, right? We need to find a designated port per segment. What is the meaning of segment? The meaning of segment is whatever the link you are saying, the point-to-point link between two switches, it is going to be your segment. So how many segments are there? You can say that this is going to be my segment number 1 because this is between switch 1 and switch 2. This is going to be my segment number 2, which is switch 3 and switch 2. And this is going to be my segment number 3, right? So what I'm saying, for now, let's leave why behind designated port for now. I will be definitely explaining you, but let's calculate it first. And you will be amazed to see that why we are doing it, right? Let's calculate the designated port. The meaning of the designated port is, right, if I am on a particular network, right? If I am on a particular segment, which switch or which port is sending the best BPDU? Now let's see that, right? Suppose in case of switch 3, I would say switch through and what is the definition of best also we need to define, right? The best means the low cost, right? This switch 3 is advertising the BPDU with the lowest cost. The cost means the cost to reach the route, right? Because this is the route, right? That is why it is advertising cost of 0. It is as simple as that. Because this is the route, right? But when this guy advertises the cost to reach the route, it is going to advertise the cost to reach the route is 10, right? It is as simple as that. Who is sending the best BPDU on this segment? 0/1 is sending the best BPDU on 1. That is why it is going to be designated port. By the way, all the ports on the route switch is your designated port because route switch is sending the best BPDU. Meaning of best BPDU is the meaning of best BPDU is which is having the lowest cost towards the route. And this is the route. And that is why the same reason we are going to have designated ports, right? So we need to find one port per switch as a route port. We need to find one designated port at least per segment. And here is the thing, we haven't find that one in number 3, right? So let's calculate, right? Who is advertising the best BPDU here? Interesting, right? When it advertised the best BPDU from here, sorry, now let's talk about the switch 2 and switch this guy, switch 1. If you see that this guy is advertising the cost of reaching BPDU with a cost of 10, you know the reason? The reason is because this guy is just 10 away from it. When this BPDU reaches here, right, then switch 2 is going to add the cost of 5. But right now, what switch 1 is advertising? Switch 1 knows that it is 10 cost away from the root bridge, and that is why it is advertising. So it is advertising the BPDU which is having 10 cost in it right here. And switch 2 is also advertising that it is 10 cost away. So can you decide on the basis of this cost value which is the best BPDU? No, absolutely not. Previously, why you were able to? Because switch 3 was advertising the cost 0 here in the BPDU, right? And receiving, of course, the 10 cost from switch 1. So which one is the best? 0/1 is the best. But here is a problem. Both the switches are advertising that they are 10 cost away from the root switch. Nobody can decide which is sending the best BPDU, right? Interesting. 0/1 is advertising the BPDU with 10 cost. It is receiving the BPDU with the 10 cost. Everybody saying that I am 10 cost away. And my neighbor is also saying he is also 10 cost away. So on the basis of cost, it cannot be decided. You all know for the, right? We need a tiebreaker here. So again, it says whoever, and you all know that this BPDU, whatever is coming from this side or this side, it is going to contain the cost as well as MAC address. And we all know that the MAC address of this guy was D.D.T and this guy was E.E.E. We cannot decide what is the best BPDU on the basis of what? The cost. Now there is another criteria on which we can decide. The other criteria is again the lowest MAC address. Interesting. We just want to break the tie, right? What is the lowest MAC address here? The lowest MAC address is D, right? It means that switch 1 is advertising a BPDU which is going to have the MAC address value D dot D dot D and the cost as 10, right? But what switch 1 is receiving? Switch 1 is receiving a MAC address E dot E dot E with the cost value of 10. I am saying that on the basis of cost, we cannot decide who is the best. I can decide on the basis of MAC address. Now, switch 1 has both the switches to compare. That I am sending it with 10. I am receiving a BPDU which is having 10, but my MAC address is better as compared to switch 2. And that is why I am going to decide that I am sending the best BPDU on this segment. And if I am sending the best BPDU, this port is going to be the designated port and this port is not going to be the designated port. Why? Because it is receiving the best BPDU. And as I mentioned, the definition of designated port, you need to find a designated port per segment, right? And a designated port is a port which is sending the best BPDU, not receiving the best BPDU. It should be sending the best BPDU. Right? So if you consider 0/2 on switch 1 or 0/1 on switch 1, 0/2 is sending the best BPDU. Why? Because it is having the lowest MAC address as compared to switch 2. It is as simple as that. So over the segment, we were deciding on the basis of cost that 0/1 is sending 0. And that is why it is the best BPDU sender. That is why it is a designated port. This is a designated port. It is as simple as that. Right? Now let's remove everything from here. Let's clear the board and see what we have discussed till now, right? I was thinking that I can complete this topic in half an hour, but yes, it's already 40 minutes and we are no way closer to finish it, right? But yes, we have discussed all the steps. So first thing first, let's find the root bridge. You all know about it now. This is the step number 1. This is my root bridge, right? Step number 2, let's find the root port, and root port need to be found on every non-root switch. What are the non-root switch? Switch 1 and switch 2, and you all know that 0/1 was the root port because it is most nearer to the root bridge, right? This is again the root port, right? Then we were finding step number 3, find the designated port per segment. Please remember root port per switch because there is going to be only one port which is more closer to the root, right? It is as simple as that. And now there is, although there could be, okay, we will be talking about it. So designated port, right, per segment. And we found that all the ports of the root bridge are definitely going to be the designated port. You know the reason behind it, right? Because this is the root bridge and 0/1 and 0/2 anyhow are going to send the best BPD out of them. Nobody else can tell them that if I am the root bridge that you can reach to me via reach to me to reach to root, right? Because I am the root, right? It is as simple as that. And if we talk about on this segment, there was an interesting thing happening, and we came to know that designated port is 0/2, right? So if a port is not a root port, if a port that is not a designated port, that port is going to be blocked by STP. Very, very interesting, right? Now things are going to be more clear to you. Now I'm talking about a port which is not the designated port, not the root port. And what is that port? That port is this one, 0/1, because this is not a root port. This is not the designated port. And that is why we call this port that it is not fitting into my spanning tree topology. I need to block this port. I need to disable this port, right? Interestingly, right? So Don't you think that whatever we would like to achieve, we have already achieved? Why? Because as an overall point, right? This is the designated port. This is the root port. This link should be up and running without any doubt. This is the designated port. This is the root port because this link consists of two interfaces. Everything means it, whether it should be a root port or designated port, it should be up and running. No doubt about it. But here is the problem. I can find one designated port, but the other port is the blocking port because it is not fitting into the category of root port or designated port. That is why I will be blocking this link. If I say I, now spanning tree is going to block this link, right? It means that if address resolution protocol frame comes here, because this is link is blocked by STP, you can definitely check that this link is going to be blocked by spanning tree protocol because spanning tree protocol says if you on this, then there is going to be definitely loop into the system, right? Address resolution protocol message will be going here, it will be coming here, but this switch is not going to be forwarded here. If there is a ARP message which is coming from here, it will be going here, but this here it won't go because the port which are shut down by the spanning tree cannot take data, and ARP is a kind of data. It is interesting, right? But now you all know for the fact that spanning tree has taken the decision on the basis of these cost value, whatever we had here, right? It says this link has gone up, this is up, but this should not be up and running because this is my designated port and this is my blocking port. But interestingly, I would say no data can transfer over this link, right? Otherwise, it would make the loop. But spanning tree says, what do you think that if suppose somebody come here, Mr. Rahul came here, he is not liking your network and he has plugged off this cable 0/2. Now there is a problem, right? What is the problem? This link is not there at all. And this link is shut down by the STP. Then means switch 2 is totally isolated. This host cannot reach anywhere, right? So this should be the responsibility of a spanning tree protocol that if it doesn't find a loop in the system, it should be make sure that this gets automatically on once again. How is that thing going to happen, right? Unless you do not come to know about it, right? Let's talk about it. So somebody straight away says that take out this link, right? So by default, guys, I am saying no data traffic can flow over this block port, but BPDUs can be sending, right? BPDU means Bridge Protocol Data Unit. Why bridge? Because at that point of time, everybody was we had only bridges, not the switches. Bridges are pretty close to the switch, right? So although this blocking port by STP cannot send the ARP messages, but it continuously sending the BPDUs, right? And of course, this switch 2 will not be receiving the BPDU from here. Why? Because this link is down. It means that this port is never ever going to be root port. Why? Because this port is not there. And spanning tree protocol says that you need to find a root port on every switch. Of course, this switch is going to have only this port. Doesn't matter if you are reaching here from in 500 kilometers or 700 kilometers. This is the only port. So this will become the root port. And of course, this is going to be your designated port. It means that this will be up. This will be up. It's as simple as that. Okay. Interesting. I am open for your questions now. Although I have a few more things to talk about for the spanning tree protocol. But if I repeat the process once more, I am repeating it for you, right? Right? Very, very simple. At the end of the day, somebody has said that the cost is here is 10, the cost here is 10. The lesser the cost, the good is for me, and the cost is here for 5, right? If I do not do anything, ARP is going to create havoc in the system. Everything is going 100% CPU, which you do not like. That is why you are taking the help of spanning tree protocol. A spanning tree run on its own. You do not need to do anything. Whenever you boot these systems, there is a election of root bridge on the basis of smallest MAC address or the priority. This root is going to be selected as the bridge, the root bridge. It is as simple as that. all the ports on the root bridge are going to be your designated port because these are sending the best BPDUs out of it. Best means whoever is sending the BPDU with the lowest cost or the MAC address. Here it is sending with 0, receiving with 10 from all others. It means that this is the designated port. Every other switch is going to find the root port. This is my root port because I can reach here to the root bridge in 10 cost, but from here I will be receiving 10 plus 5, right? The BPDUs of 10 plus 5 and BPDUs of 10, of course, the BPDU of 10 is better, and that is why this is going to be my root port. This is going to be my root port here too. Here, I need to do some more calculation. This is the segment. Who is sending the best PPD? Of course, 0/2. Not on the basis of cost, but on the basis of MAC address. This guy is having the lower MAC address as compared to this one. It is going to be my designated port. But believe me, if this guy had the lowest MAC address, then it would have been your designated port, this port, right? If a port is not categorizing in anything like designated port or the root port, it is going to be blocked by spanning tree. If this is blocked from here, doesn't mean that we can send data traffic from here. No, this port is completely blocked. And that is what Punish was showing you. One portion was green yesterday and one portion was yellow. Yellow portion was blocked by STP. It is as simple as that. But as I mentioned, you cannot send data traffic like ARP or unicast message. But yes, these BPDUs will continuously be flowing over this link. So that if somebody can plug this out, can plug this cable out, this link should be up and running, right? Why? Because now previously this was your root port and somebody has just take this link off from the switch tree, right? If that is the case, nobody is sending you the BPDU. It means that after some time, after how much time, we will talk about it. But after some time, 0/2 comes to know that definitely I'm not receiving the BPDUs, right? This link is not working. It means that the other link, which I only have the link, if I'm receiving the BPDU, it is really good to make that a root port so that you can reach at least from here. There is the case of the failure, means somebody has plugged this cable out. This is what I have discussed here. If you have any doubt, any question, please do ask. Or at least I need a hand raise from everybody here that you get something out of this board. Okay, perfect. There are still so many people who are not raising the hand. And interestingly, the people are same all the time, right? Okay, okay. Many of you have raised the hand. Good, good, good. I am again and again saying this topic is really, really important. Punish, do we have any question from anybody?
No, no Vishnu.
Perfect. Oh, Dhaval is also here. Hi, Dhaval.
Yes.
So this is the spanning tree protocol, but believe me, this is the thing which came first, right? Which solved this problem first, right? But there are a lot of changes now in this spanning tree protocol. As I specifically mentioned, that we are increasing the efficiency. We just now uh, broke this loop here by using the spanning tree protocol, right? I think this is known as 802.1d, which is called a spanning tree protocol, right? Yesterday we talked about 802.1q, right? That is the trunking. So 802 standards are very, very important if you want to learn switching, right? Having said that, even the Ethernet is 802 dot something. You can go and check on, but Google. But now we want to explain you a few more thing here, right? And that's from the certification point of view, right? So we understand that how spanning tree protocol is going to block some of the links, right? But there are some more things, right? And what are these? So what is happening, guys? We talked about this BPDU. You all know that to begin with, every switch is going to say, I am the root, right? But after the election, only BPDU is going to generate these, only the switch, which is a root switch, is going to generate this BPDU. All other switches are going to just forward it, right? By adding their respective cost. For example, this is the guy who is sending the BPDU with the cost value of 0, and their MAC address, maybe the MAC address is CCC, right? When it receives here, and this guy want to send it here, it will add the cost of this link, whatever, the 10, and again it is going to forward it like this. Interesting, right? But after how many times these BPDUs are going to be, right? Going to be forwarded. So the time distance between two BPDUs is actually 2 seconds by default. You can change it for sure. But if switch 3 is generated a particular BPDU, it is going to send another BPDU, and the time between them is 2 seconds, and we call this time as hello time, right? Interesting. Now, suppose this guy was the root port, right? And somebody has done something in this wire. I do not know what. It means that if somebody has done something in this wire, then this switch is sending the BPDUs, but this guy is not receiving the BPDUs, right? After how much time this switch 2 should say that, boss, now there is some problem, because BPDUs are the heartbeat of the system, right? If I'm receiving the continuous BPDU on my root port, right, from the root switch, right, then it means that the path to the root is great. There is no doubt about it, because only the root bridge is going to generate these messages. And if I'm receiving these messages, then basically my root is working fine. This is still the root port, right? No doubt about it. But now somebody has broke this cable, or somebody has break. If that is the case, if somebody has broken this cable, then I will be missing one one BPDU. Then after 2 seconds, two BPDUs. There is not going to be BPDU. After how much time I should say that this is not anymore the root port? Why? Because I'm not receiving. I am continuously missing the BPDUs. And by the way, by default, if you miss 10 BPDUs, if you have 20 seconds and you do not get anything, right, then it is a problem. In 20 seconds, if you are not receiving any BPDU, it means that you have missed the 10 BPDUs. And if you have missed the 10 BPDUs, this switch to understand that now there is some major problem with this link. I would say this is not my root port. This was the blocking port, but this is the only port now I have. So switch is going to say, now this is my root port, because somebody has closed this link, say. Very, very interesting, right? So this time period is actually known as your max age time. What is the meaning of max age time? This is the time over which whatever you are learning, for example, switch must be building the CAM table, because suppose if we have three PCs here, right? It must be saying the PC number 1 is connected to 0/2. PC number 2 is also connected to 0/2. PC number 3 is connected to 0/2. Why? Because suppose these are your MAC address, PC1, PC2, PC3, and this is how switch creates a CAM table. And now it's find that 0/2 is no more available. Why? Because somebody has broken this link, right? If that is the case, then do you think that these entries should be there in the CAM table? When after this max age time, the first thing first this switch is going to do, it is going to flush out these entries. Now, why? Because nobody is there, right? Interesting. So this is the max age time, which is 20 seconds, right? One more thing. This ports of the switch, right? This 0/1, 0/1, right? Here and here. Spanning tree protocol is extra cautious. that there should be no loop, even if we are building this, if we are initializing the process of STP, because you understand when we send the BPDUs, BPDU will be received, we are going to do the calculations, right? We do not want to do that. That during that period too, that there is going to be loop. So when this port comes up in the spanning tree, the 0/1 port comes up, the first thing first, it should not be going into the forwarding mode, right? Because you never know, it could lead to the loop, right? So first thing first, it will be going into the listening mode for 15 seconds. During this period of time, it cannot forward right? It is just listening for the BPDUs, doing some calculation. Then basically it is start in the learning mode for another 15 seconds. 15 plus 15, 30 seconds. These are the two states in which this port has to go. In the learning stage, again, it is not sending any packets or frames. It is just start learning the packet. That if somebody is sending ARP or something, then basically it is going to fill its CAM table of the switch, right? So spanning tree protocol is extra cautious. It is saying it is not putting the port directly into the forwarding mode, right? Okay. It first put them in the listening mode, learning mode, and after 30 seconds, when it is convinced that, okay, now everything is fine, I have learned something, it is moving it to the forwarding state, right? Interesting. These are the port state. And maybe if time permits, Punish is going to show you that yes, whenever the port comes up, it is going into the listen, then learning, and then forwarding, right? So if you switch on a port, it is definitely not going to do anything for 30 seconds. And that is where most of the network engineers get confused. That I have connected a cable, I am starting pinging, and no ping is there. Just wait for some time, right? And by the way, in current network, this 30-second period is too much. We can't wait for this listening and learning time, right? And that is why there is a new protocol, which is known as rapid spanning tree protocol. Most of the things are just like spanning tree protocol, but it is rapid because it has removed few of these states, like it's totally removed the listening state and reduce this time period from 30 to 15 seconds. But yes, we will be talking about it, not much, because believe me, if I explain you RSTP, it's a new protocol, which is more efficient as compared to spanning tree protocol. It has so many things. If I explain that, it is going to take me minimum 4 to 5 hours in explaining that RSTP to you, right? And the CCNA syllabus says only RSTP. You cannot understand RSTP if you do not know what are the problems with STP. You have to understand STP first to understand rapid spanning tree protocol. We will be talking about it, but in short, right? By the way, the time a port spend into a particular state, like listening or learning. For example, as I mentioned, 15 seconds in listening, 15 seconds in learning. This is known as your forwarding delay. Okay. What is a forwarding delay? The time a particular port spent into a particular state is known as the forwarding delay. These are just the terms which are going to be very, very important when you're giving this exam, right? But I would say you should understand them, right? Because there is a proper region of hello time that we should know that after how many after how many seconds these BPDUs are going to be forwarded, right? We should understand that how much time I should wait to declare that now I'm not getting anything out of this link. So let me look for some other link. It is as simple as that, right? Interesting. Now let's go to another board where we are going to talk about per-VLAN spanning tree. And what is the meaning of per-VLAN spanning tree? Again, these are from your CCNA syllabus, right? So by default, you all know that what is going to happen if we have multiple VLANs on a switch, right? What is the meaning of VLAN, right? You all know about it. So by default, spanning tree runs per VLAN. But what is the meaning? Why spanning tree is running per VLAN? What extra problem it is solving? Suppose I have one VLAN here, which is my VLAN number 10, another VLAN here, which is my VLAN number 20, right? It could be the case, right? This could be part of my both the VLANs, right? Why? Because this is the trunk links. A trunk link can carry traffic of multiple VLANs, right? And suppose I have only one, for now, if I have only one VLAN, suppose VLAN 10 here, VLAN 10 here, it means that the trunk is carrying traffic of only VLAN 10. You all know about it, right? So what traffic should be going on here? Suppose I take everything as 10, 10, and 10, right? And in the VLAN 10, basically this bridge is known as my root bridge. Then this link is going to be up, this link is going to be up, this is going to be down, right? So this trunk link is not sending traffic for VLAN number 1. But what if somebody has decided that VLAN 1 traffic is going like this, between the switches like this, right? You can decide that if you have another VLAN, suppose VLAN number 20 here, this traffic should go like this. And for the VLAN 20, this should be blocked, right? And why I am going to say that? Again, I'm repeating. If I have switch 1, if I have switch 2, if I have switch 3, see my problem. Right now, all these are trunk links. And if I do not do anything, this link is going to be blocked by TCP, right? Sorry, by STP. But suppose this was my 10 gig link, this was my 10 gig link, this was my 10 gig link too. I am not going to utilize this 10 gig link at all because spanning tree is always going to block this link for me, right? So what I can do is I can do that these trunk links should be up for VLAN 1, right? But these trunk links should be up for VLAN 20. So this link is not going to be down for all the VLANs. Maybe it is forwarding the traffic of 10 VLANs and blocking the traffic of 10 VLANs. I'm talking about if we have so many VLANs here. If you do not get it, that is perfectly fine. If you do not get anything out of this board, that is also fine. But yes, to understand this, believe me, you need a solid understanding of VLAN. You need a solid understanding of spanning tree protocol. Why? And we just understood spanning tree protocol, right? We all know that a switch is going to contain multiple VLANs, right? If there is only if there happens to be only one VLAN, VLAN number 10, then no doubt about it. Whatever the link we have, then we are forwarding, right? And for VLAN 10, we have just blocked this link. But what if I do not want to do that? I want that this link should be up for some other VLANs, right? I can do that. And by the way, spanning tree protocol runs per VLAN by default. This is the invention of Cisco, per VLAN spanning tree. So normal standard says that you should run only one instance of spanning tree protocol. For all the VLANs, only one instance is running, right? Then you cannot do these cool things that for all the VLANs, this link is going to be blocked, right? This is per VLAN spanning. You just need to think. If you uh, just learn VLAN, if you see the video of VLAN, right? If you see once again the spanning tree protocol, and if you start thinking about it, then definitely this idea is going to click you that per-VLAN spanning tree is actually much more superior, right? Because you can create multiple topologies out of it. If you do not get it, that is perfectly fine. Having said that, let's move to the new board, which is rapid spanning tree protocol, right? As I mentioned previously, that we have blocked port in the case of spanning tree protocol STP. Then we have listening status. Then we have learning status, and then we have forwarding status, right? Now, what spanning tree protocol has done is it is only having not this is not having these four different port states. It is only having discarding, learning, and forwarding, right? Discarding means block, so basically it is converted this blocked and listening mode into the one, which is going to be a discarding, right? So of course this is fast. Why this is fast? This is fast because it is just removed 15 seconds out of the picture. Because in the previous protocol, the spanning tree protocol, there was a state which is known as the listening state. It is as simple as that, right? Now, one more thing, just try to understand that when we calculated everything, we know that this is going to be my root port, right? This is going to be my root port on this switch. And now this port is going to be the blocked port. I know this for sure, right? But try to understand one thing. Can this switch is intelligent enough to know, right, that I have only two ports. I have one root port and one backup port, right? Previously, what used to happen, why spanning tree protocol was slow, that somebody if has blocked this link, right, then it will be waiting for how many times, how much time? It must be waiting for 20 seconds to know that nothing is coming. Now this is not the root port. And now basically I need to make this as a root port, right? Then again it is going to start from listening, learning, again 20 seconds. So 20 seconds from here, and then 15 plus 15, 30 seconds from here. Then it is going to make 30 plus 20 seconds to know that this link should come up if there is nothing called this, right? Interesting. We need to wait 30 plus 20 means 50 seconds so that this link comes up. If this goes down or something happens to this link, right? This is slow. These 50 seconds is not acceptable at all in current networks, right? So what what rapid spanning tree is doing, just try to understand. It sees that this is my root port. It sees that this is my block port, but it also says that inside this block port, basically I'm assigning another port role to it. Although this is the block one, but actually this is my alternate port. This is my alternate port to reach the root bridge, right? If something happens to this, I should immediately make it up and running. Why? I do not need to wait for listening, learning, and so many things, right? 15 plus 15. And rapid spanning tree is also decreasing this time period, right? The max age time. You do not need to wait for 20 seconds to come to know that there is something happened with this link, right? So if we are reducing this max age time, if we are saying that once I confirm that there is a problem with respect to the root port, whatever my alternate port is, what is the meaning of alternate port? Alternate port means that you have another way to reach the root port, right? Or the root switch. If that is the case, if this goes down, if I come to know that this is not the root port, I will immediately make it as a root port. My alternate port is going to be immediately become the root port. It is as simple as that. So rapid means We are just removing some of the inefficiencies of spanning tree protocol. We have removed listening state. We have shortened the message time period. We have introduced one more term, which is the alternate port, right? Which we can definitely say that if my root port goes down, alternate port is going to become the root port, right? I'm saving some 30 seconds here, 15 seconds here. You can see that rapid spanning tree protocol is really doing great. But believe me, in current network, whether it's STP or RSTP, nobody wants them. If it is taking even 5 minutes, right? Nobody wants them. And the reason is straightforward. Nobody wants these delay, right? Do not make such topologies which are having this loop. You are not going to have spanning tree protocol. But yes, try to understand what if you are creating a topology which is loop free, you are creating this topology. What if somebody comes and connect these two, right? This is going to be a huge problem, right? Into your network. So you cannot rely on the fact that I will never ever make a topology, right, which is loop free, because if you are capable enough of understanding that other people can do that loop in your environment, it happened in the past also, right? That the customer has deployed this topology, right? And they have shut down the spanning tree protocol together, that they are pretty sure that nobody is going to do that, but somebody has make sure that this is now the loop topology, or they have connected the cable, and that is the case, then their complete network was down, complete layer 2 network was down. Interesting, right? So you cannot be dependent on the feeling that I will never ever create the looped physical topology. If you are not going to do that, somebody else can do that, right? One last thing I would like to tell you before going on to the break is this one, right? Host A and host B, these are connecting. And you all know for the sure that when I connect it, spanning tree will be running on this protocol also, right? Spanning tree will move this into the listening and then learning and all those things, right? Your 15 plus 15 seconds are wasted. But you all know that this is just the host, right? This is just a plain host which is connecting, right? So can I do something through so that the spanning tree protocol does not need to go to the listening learning to make this host available on the network as soon as possible, right? And what you can do here on such ports where you expect that only hosts are going to coming and host endpoint, then you can configure a feature here which is called port fast feature. You just go into this interface, maybe 0/3. Punish can show you interface 0/3. You can just write down here spanning tree, whatever, and then you can write port fast. If you write it, the system will understand that, okay, 0/3 is a port fast port. This guy is expecting only the host connecting to it. I will never ever go to the listening and learning form, right? Interesting. So this is how the port fast works. What is the benefit of listening and learning delay? Right? This is the question asked by Vedant Goswami. So if this port is going into the listening and learning, the major benefit is, see, when this port comes up, it never knows that if I should, suppose these were the two things which were only into your system, right? Switch 3 was connected to switch 2, switch 2 was connected to switch 1, and now you are bringing this link up. Suppose if you straight away move this port to the forwarding port, then it is going to be a problem. There is a loop in the system, right? So spanning tree protocol is extra cautious in doing that. It is moving this thing to the listening and learning. Listening means that you are getting the BPDUs, you are taking the note that who is the root bridge, who is doing what. Then learning means whatever the ARP is flowing or the messages are flowing, you are making sure that your CAM table is filled. You need some time to know that You are not creating the loop into the system. Okay, Mr. Vedant Goswami? This is the reason. Now, one more thing, just if you can just put some brain, right? What we are going to discuss now, it is going to be the basis of the next topic. Suppose we have two switches, switch number 1 and switch number 2, and I have connected two interfaces. Interface, maybe this is 0/3, this is 0/4, this is 0/1, this is 0/2. Do you think that we are having a loop in the system? Absolutely, we are having. Suppose this guy is A, this guy who is connected here, which is B, this is having MAC address of B.B.B. This is having MAC address of A.A.A. When they start pinging each other, A is going to send the address resolution message, which is the broadcast. It should be going here as well as here, right? And when it reaches here, it will be forwarding back to here and now here. So basically, we are seeing the loop here. In this simple topology too, we are seeing the loop here, right? If you want to do this exercise, just have two switches, connect those two switches with only two interfaces, just do a ping, just shut down the spanning tree protocol from these two systems, and you will be amazed to see that these two systems will be reaching 100% of the CPU, right? You do not want to do that. It means that in this simple topology too, spanning tree protocol will be running. Suppose this is my root switch. Suppose the priority of this is say 1, and then basically MAC address is B.B.B. Here the MAC address is A.A.A, and the priority is suppose 128. Which is the best bridge? This is going to be the best switch. This is going to be my root bridge. And here this port is designated port. This port is designated port. Now my question is, if these two are the same cost, 10 and 10, right? I need to find what is the root port, because 0/1 can be root port, 0/2 can be root port. So the first criteria is going to be waste, right? Because the cost, whatever I am receiving here over this port as well as this port, is going to be same. Switch is advertising the BPDU with the 0 cost, right? When it adds 10 here at the switch 2, both are going to get the 10. And it means that I cannot decide whether 0/1 is the root port or 0/2 is the root port. So the first thing first, on the basis of cost, I cannot define. The second thing comes, can I define on the basis of MAC address? No, absolutely not, right? Why? Because the BPDU which is coming from top is from the same MAC address, also from the same switch. The third thing on the basis of which I decide is basically my port priority. The port priority depend on this number, because we are just breaking the tiebreakers, right? We are just want to make sure that whatever is happening here, I want to break that tie. So 0/3 is the lowest port which is advertising it, right? And 0/4 is the highest port which is advertising this. So the bridge protocol data unit which is coming from the lowest port ID is considered to be the best. It means that this port is going to be a root port, and if this port is not fitting somewhere, then this is going to be blocked. This is very, very interesting thing, guys. And believe me, most of the network engineers cannot deal with this simple topology, that which is going to be the blocked, right? The idea is going to be very, very simple. You just need to break the tiebreakers, and that is it. Interesting, right? But here is my thing. If we have these two switches, and suppose I want to have these three connections up and running between them, the spanning tree protocol will never ever let me do that, right? Because it is going to block at least two, so that there is no loop. If that is the case, How I am going to build the redundant topology? What is the meaning of redundant topology? Suppose if I have switch 1 and switch 2, right? If there are multiple hosts, hundreds of hosts connected here, hundreds of hosts connected here, don't you think that it is dependent on this single link? If this link goes down, then it's my problem, right? But you must be saying that if this link goes down, then Mr. Vishnu, this will be up. But yes, this will be up after 5 or 6 seconds. I do not want to do that. I want at least 2 links should be up all the time. So if this goes down, then basically somebody else can take that messages for me. And believe me, that is going to be the next topic, which is Ether channel, which we will be discussing when we come after the break. Okay. But with that, if you do not get anything out of this board, it's a problem then. You should be seeing this video once again, right? If not, whatever comes to your mind, means if I am writing here 2 plus 2 is equal to 4, guys, do not hesitate asking questions, right? Asking questions is good. You can clear your mind. Whatever comes to your mind, please do ask your question. Mr. Dhaval, Mr. Rohit, Mr. Punesh, do we have any questions from anybody?
No, Vishnu.
Perfect. Okay. So again, I'll take a poll. How many of you understand this board, whatever I have explained on this board right now? Can you please raise your hands? And I can definitely ask some questions who is not raising hand that what they didn't get. Now I'm seeing a lot of hand raises. This is good. Okay. So let me ask Ayushri. Ayushri, you there? Ayushri Avantika, you there? You can unmute yourself. If you're talking, then you're talking on mute. Ayushri, you there? Okay, interesting. Avantika, are you there? Okay, let me ask. Shubha Sharma, Simran Panda, this is amazing. Interesting. Okay.
My hand, I don't know, there was some glitch, but I just heard my name. I was trying till then, so yeah, sorry.
No, that is perfectly fine.
But
See,
I
the whole soul,
understood.
yeah, the whole soul intent is that you get. There is nothing like that. People are going to spy on you that whether you are working, you are learning or not. That is perfectly fine, right?
Yes.
So if you
Yes,
get something on out of this board, my intent was that if you haven't raised your hand, then it must be that you have some question in your mind, right? So if you have any question, anybody has any question, please do ask. Having said that, let's take a break of maybe half an hour. We will be getting back at 11:34. See you then. Bye for now. Welcome back once again. And we were on this board, and this was the board which is a problem for many network engineers. And believe me, these are some of the questions which have been asked in CCA exam also. So if we talk about the next topic, and we all know that we have the base for this just in previous board. So first thing first, we are going to do is why behind ether channel, right? So ether channel is just a name for you. You have just heard about it. That is perfectly fine. But we all know for sure that if we have these two switches, switch number 1, switch number 2, right here, right? And they are connected. Maybe they are connected to these three interfaces, sorry, these two PCs, and here, these three PCs. You all know for sure, right? If you do not do anything, these PCs are going to communicate with each other, right? If you do not even do anything, You just connect these two switches. These link are going to be trunk link automatically. But if you do not see them coming up, then you need to run a command like uh, interface trunk. You need to define the encapsulation .1q, and that is it. Punish shown all these things in yesterday's class, right? But here is my problem. The problem is if I connect two switches, switch number 1, switch number 2, with multiple ports, maybe this is say 0/1 here, 0/1 here, 0/2 here, 0/2 here, and 0/3, 0/3 here, right? If we have 3 ports connected, then by default, if we are running spanning tree protocol, because spanning tree protocol also run on its own by default, when this switch comes, it is going to find the root bridge in the complete topology. Once the root bridge is fine, you all know the process. And spanning tree protocol is going to shut down some of the links to avoid network loops. If that is the case, maybe, I'm not sure which link spanning tree protocol is going to decide, but for now, let's see that this link and this link is down by spanning tree protocol. Then we all know that at one or at a particular time, only one link is going to be up and running. All the traffic which will be flowing from here to here over single link, right? Interesting. And suppose this link is only having maybe 10 Mbps link or maybe 100 Mbps link, suppose, right? But try to understand that you have placed some servers here in this part of the network, and then basically somebody is downloading a movie or a file from the server, which is a huge file, 5 gigabyte file, suppose. Then you must be understanding that if all these computers start doing that, then this link will be oversubscribed within no time, right? Although you can see that you have 100 Mbps, I think you have 3 links here, but because of the spanning tree protocol, only one link is up and running at that particular time. And if that is the case, then this is a problem. We are never ever going to utilize these 2 links, right, which is shut down by the spanning tree protocol, because spanning tree protocol job is to avoid the loop. Its job is to make sure that these 2 switches does not sorry, these 2 switches do not reach to 100% CPU because of the address resolution protocol request broadcast message, right? And that is why it is going to avoid the loop. But in this process, actually, we are sacrificing a lot of things, right? First thing first, we have only one link always up and running. Other links are going to be blocked by STP because it doesn't want to create the loop. It is as simple as that, right? So guys, I want a quick poll here. Do you understand the problem, right? Previously, we understood straight away, right, that we were learning switching, and in the switching concept, because of the address resolution protocol can create the loops, that is why we came across spanning tree protocol. But now spanning tree protocol is creating some issues with respect to efficiency of the system. Why efficiency, right? Because although we have 300 Mbps of 3 straight lines, but we are using only 100 Mbps right here. Interesting. And if we are using only 100 Mbps, if we are not using, this is a problem. And as I mentioned, that now you understand the complete networking, because you know how do computers talk inside a network, how do computers talk when they are miles away in different network. We are day by day actually increasing the efficiency of this system, the TCP/IP model, by reading, by learning new concept. And right now we are seeing that in switching there was some issues. That's why we are having a spanning tree protocol. Spanning tree protocol leads us to some more issues, although it has solved the previous problem, but now we are having some more issues that we cannot use all the links at once. We have to use only one link between two switches, right? Which is not a solution, right? We want to use all the links, and if we want to use all the links, then it means that STP should think that these three links are not three links. This is one link. How to make sure that STP or spanning tree protocol does not presume these three different links as three, but on the contrary, it will be presuming these as a one link. And if it can do that, then basically this link can be up and running, because for the STP, it is a one link, right? But how to do that? We are going to talk about it, right? But I believe you understand the problem. Now we are going to give you the solution, right? The technology which can fool spanning tree protocol, that Mr. Spanning Tree did not presume these three links as three, but presume these as a one link. The technology name is Etherchannel, right? We will talk about it, but I can see that there are two hand raised. One is from Romil Jan and the other one is from Sidhu Bomu. Do you have any question? Romil and Sidhu? No, there is no question. So I think that the hand was from previous uh, incidents, right? Having said that, do you guys understand? Everybody understand? Whoever is here in this class, do you understand that there is a problem in this spanning tree protocol? Can you just raise hand that if you get 100% out of this board, right? This is very, very important. Okay, interesting. So basically we are getting a lot of hand raises. This is good. This is perfect. Thank you so much. Now, let's see what is the solution of this problem. And here you go. To understand the solution of this problem, one thing is clear to all of us, that spanning tree protocol needs to think these three links, not three, but one. And this is what exactly this technology, which is known as Etherchannel, is doing for me. Etherchannel says that now these three links are not different links. These are part of the same bundle, right? Which is shown by this yellow ring. And now spanning tree protocol, which is running over this switch, now it is saying that I do not see these interfaces as three different interfaces, 0/1, 0/2, 0/3. So the spanning tree protocol is not seeing them as a single at three different interfaces, but because of this technology known as Etherchannel, Etherchannel is informing STP that Mr. STP, there are no three links. There is one bundle link, and maybe you can write this bundle link name as port channel PO1, right? So basically, Etherchannel is somebody who is actually does not let STP knows that there are three links running. For STP, there is only one link, which is named as bundle link or Etherchannel link. We also call it a port channel or channel group also. There are so many names, right? So to STP, we are informing, this Etherchannel technology is informing that there are no three links now here, right? There is only one link, which is known as port channel. And now, instead of these three links, we can configure these three links at once. We will be writing this is not 0/1 interface of the switch. This is port channel 1 interface of the switch. Similarly here also, because there are two ends of this link, right? We are having two switches here. This is port channel 1. This is port channel 1. We need to define how many interfaces we want to make sure which are part of this group. right? You can call channel group, you can call it port channel, anything. But at the end of the day, what this port channel PO1 contains, this contains interfaces. How many? It depends on the technology which we are using, right? So generally, basically, we can have 8 to 16, or basically more than 2 to 16 interfaces inside this channel, right? But again, I'm repeating this once again, that spanning tree protocol is not going to see these as a 3 links or 4 links, whatever inside in this bundle. It is going to see only one link, port channel. It means that you need to specify somewhere that I am using ether channel technology, right? I am using Etherchannel technology, which is having these 4 links, maybe 3 links or 2 links, whatever, 0/1, 0/2, 0/3, 0/4. And now I want to use them as a single link, right? And this is informed by, and now Etherchannel is calling them all these 4 links with the single name, which is PO1, and it is informing STP that now this is only one link. Do not consider these links as 4 different links. Otherwise, you would block 3 out of the 4, which I do not want. So now if we include Etherchannel technology, STP does not have any clue about it, that these are separate interfaces. What STP is going to see, it is going to see that it's a single interface port channel 1 on both of the switches. And that is why all the links of these are going to be up. It means that few flows from this PC to this PC are going on one interface. Other flows can go on other interface, right? And suppose I have this 10 gig link, right? And now I am making 10 gig link plus 10 gig link plus 10 gig link, because there are 3 interfaces, right? Which I'm saying that these are the one. It means that we are having single 30 gig link. This 30 gig link is seen by STP, not 10 gig every link. And now you can understand, I can straight away forward 30 GB gigabits of data per second, because now the complete capacity of this link is 30 Gbps. Just try to think, if we combine 8 links of 10 gigs, it means that 80 Gbps data can flow. If we do not have ether channel, it is going to be for sure, if you include 8 links between the 2 switches, STP is going to block 7 to remove the loop. But now you can all see that with the use of this Etherchannel technology, STP is going to see this as a one link only, and it's not going to block it. Doesn't matter how many links you are having inside a particular ether channel, maybe 2, 3, 4, 5, 6, 7, 8, whatever the number of protocols support, whatever the number of links this protocol supports. By the way, ether channel technology has 2 different implementations, right? One is Cisco proprietary, which is known as Port Aggregation Protocol, PAGP, right? This is Cisco's implementation. So Ether channel technology was developed by Cisco, right? But then, because everybody want to use it, so there is a standard. If I say standard, any vendor can use it. So there is a new technology called LACP. Again, LACP is a part of Ether channel. The meaning of LACP is Link Aggregation Control Protocol. The meaning is you are actually aggregating the links, multiple links, right, into a single channel. That is known as Link Aggregation Control Protocol, which is standard. If you are using some other company switches like Juniper switches, and one side you have Juniper, other side you have Cisco, and if you are running ether channel between them, make sure that you are running LACP ether channel, which proves that these links are going to be compatible, and then basically this is going to be a single link instead of 3. It is straightforward. The concept of ether channel is really straightforward. But just try to understand that if we have two different switches, right? What things should match? We have switch 1, we have switch 2. We are running three interfaces between them. We are running three, sorry, cables between them. I want to make sure that Ether channel technology has some requirements. They say that whatever the ports you are including should be similar, should be compatible. What is the meaning of compatible ports? It's saying that you cannot say that the 0/1 port is my fast Ethernet port or 100 Mbps port and these two ports are 10 gig. No. Ethernet technology says that whatever the link you are combining, those should are going to be have the same speed and duplex. What is the meaning of duplex? Duplex can be full or half, and you know the difference between them. I have explained it. Full means that two systems can send and receive traffic at the same time. Half duplex means it is just like the one-way street. If somebody is sending, it cannot receive. If somebody is receiving, it cannot send the data. So this is the half duplex, right? Then there are some links which are half duplex too. There are some links which are full duplex too. But believe me, we are so much advanced in the networking technology. All the links, whatever you are going to see in today's network, those are going to be your full duplex. So Ethernet technology is saying whatever the link you are combining as a part of Ether channel, those should be the same or the comparable. That means the speed and duplex should match. If this is a trunk link, the other link cannot be accessed, right? So what you are going to do is you are going to make this as a trunk, this is a trunk, right? And once you have made these three link as a channel, right? Then of course it is going to be then a single channel, the single channel, which consists of three links in it, right? But the system is going to see that it is only one channel, maybe which is a port channel number 1, port channel number 2. And believe me guys, this is just like any interface, right? Any interface. Previously you have seen interface FA0/1. If you go inside this, you can configure access VLAN, that which VLAN should be this interface should be part of. Now you can define here that you can literally go into interface port channel 1. You can say this port channel is trunk interface mode trunk, you can say, right? Switch port access trunk, you can say. It is as simple as that. So whatever the parameters you can configure on the standard interfaces, you can configure here also. And the interesting thing, as I mentioned, a lot of time, all these links are going to be seen as one link by STP protocol. Those are not going to be blocked. It is as simple as that. So to make certain links to be part of a particular port channel, you should be considering that everything, speed, duplex, mode, should be the same on these interfaces. It is as simple as that. Now let's move to the next board and let's see what we have here. Again, I have taken another example. Now, again, we have same switches, switch number 1, switch number 2, but now instead of one port channel, I have defined two port channel 1 and port channel 2. This is the orange one where I am combining these two lower interfaces, means 0/3, 0/4. And here I am combining topmost interfaces 0/1 and 0/2. But now here the topology is looking like this, that we have two switches, right? We have two switches, switch 1 and switch 2. Okay. Switch 1 and switch 2. And now we are running two port channels. One is the yellow one, which is having topmost two interfaces, and the bottom one is the orange one, like this, right? So STP is going to see that there are two links, PO1 and or the port channel 1 and the port channel 2. What do you think, right? Will STP is going to block PC1 or PC2, or both the links should be up and running? Now STP is seeing these two, although there are 4 links, definitely 2 wires are here, 2 wires are here, but STP is going to see the 2 different port channels. Anybody can be part of this discussion. What do you think? Spanning tree is going to block one port channel or not? Anyone? Just raise your hand, just type whatever you want to do. Okay, at least tell me, unmute yourself. Did you get the problem, what I'm saying? It is interesting. Out of the 70 people, nobody is going to. Okay, at least tell me whether you get this problem or not. Otherwise, I am coming to you asking. Anyone?
Yes, Vishnu, got the problem.
Okay, who said this?
Simar.
Simar. Okay, let me ask. Let me call once again. Aditya Kumar Sinha ji. Mr. Aditya
Yes.
Kumar Sinha, can you hear me?
Yes, no. Yes, can you listen me?
Yeah, I can hear you. Perfect.
Yeah.
Did you get something out of it, or do you have any question?
Yes, I got it.
Okay. So what do you think that now spanning tree protocol is seeing those 2 different port channels, right? Aditya?
Yes,
One
yes.
is the yellow one, the other one the orange one. Do you think that spanning tree protocol is going to block any one of them?
Yes, I think one will be blocked
And the reason for that is?
because it think it as a two different.
Absolutely, absolutely. Thank you so much, dear. Right? Thank you so much. Right now, if you can see here, because I just take a name of any random person, and if you're getting it, this is going to be great, right? Let me ask other people also. If I say Mr. Ankit Biswal, can you hear me? Mr. Ankit?
Yeah, I can hear you.
Mr. Ankit ji, can you get something out of this board? Is it okay?
Yeah, yes. Actually, the STP sees that it has 2 links, so it will block one of them.
Oh, perfect. Thank you so much. You guys are really intelligent. And that is what exactly happens. You all know that now there are 2 links. STP, whether it's port channel or not, right? Both the links are port channel. If both the links are port channel, again, we can send ARP here, ARP can move back here, right? STP is going to break at least one of them. It is as simple as that, right? So this proves that you are learning something, right? Because I see problem in network engineers. I would say please go on mute, guys, whoever is not on mute. Ayushri, please go on mute. Thank you so much.
Abhinesh, what does Abhinesh mean? Does it mean anything as a random noise?
Ayushri, please go on mute. Guys, can we unmute her? Can we mute her? Okay, I think I can mute her. Okay. So Ayushi is not here for sure, it means. Having said that, let's talk about the next topic, where we are talking about concept of ether channel once again. And now let's talk about a particular implementation of ether channel, how this ether channel is implemented using LACP, which is link aggregation control protocol, right? So what you need to do to run this LACP is, first of all, you need to decide what are the different links. You want to make sure that these links become part of the ether channel here, 0/1, 0/2, 0/3, right? So you are going to define that now these two guys understand LACP. Okay, what is the meaning of LACP? LACP is just a code, right? Which is actually automating this process for you, that you do inform to LACP that I want to have 0/1, 0/2, 0/3 link to be part of my port channel. Here also on switch 2, you are going to define that 0/1, 0/2, and 0/3 links should be part of my port channel, right? You have defined there. Now, it is the responsibility of LACP protocol to build that port channel for you, right? And you can also define that whatever the bundle comes, I will be calling it PO1. And here also I will be calling it PO1. You just need to define these two things. Now it is the responsibility of LACP to check, right? It is the responsibility of LACP to check whether all these links are compatible. These are having the same speed, duplex, trunk, access, whatever the settings, right? It is easing your work. So how to do that, Punish is going to explain you, maybe not in today's, then next class. But these are the inputs which should go to the link aggregation control protocol that I want to create a port channel, which I'm thinking the name should be PO1. And these are the interfaces that should be part of that, right? So this LACP protocol runs in 3 modes, right? Whether it can be active, it can be passive, or it can be on mode. So the meaning of on is simple. You need to define that I just do not want to do any dynamic thing. I just will write here on, here on. If both are on, then basically your channel, I would like to show the channel with maybe this red color. This is the port channel which will be coming up, which consists of these 3 interfaces, right? Which are inside this. Definitely, these are the 3 interfaces. This is going to be the port channel. If you configure, if you tell LACP that I am interested in creating PO1 with these 3 interfaces on switch 1, and I am choosing a mode called on. Similarly, if you do that here, PO1 0/1, 0/2, 0/3 should be the interfaces, and you choose the mode on, this link is going to be up and running. This will be your ether channel, and a spanning tree protocol is going to see it, and it will say, now it sees only one link. That is it, right? But there are other modes of LACP too. The other modes are active and passive. So what you can do is you can say this one is active mode, and that is it. If you define this one active, by default, everything I believe runs in passive mode. So passive means this side is actually listening for LACP message, but it is not on its own sending LACP messages, right? But it is listening the LACP messages. But on the active side, if I am active, I am start negotiating with the other one that I want to make a port channel with 0/1, 0/2, 0/3. Switch to, do you have 3 ports available for you? And now, because you have done the configuration that side also, if this is in passive mode, it is replying back, yes, somebody has configured LACP on me too with these interfaces, with this port channel name, right? And now these are talking with each other on their own, right? This is what we know as protocol, because whatever the switch 1 is sending, switch 2 is responding on the basis of it, right? Why? Because they know this protocol. This protocol code is written on switch 1 as well as switch 2 LACP, right? If this is sending that I want to create a port channel with you, it is definitely going to reply that, okay, fine. So if you have here active, here passive, your port channel is going to be up and running. If you have here passive, here active, no doubt about it, it's going to be, it's the same thing, right? If you have both side active, the meaning of both side active means anybody can initiate the communication, right? It is sending the LACP message. Of course, it is replying because both understand, and your port channel will be up and running. But yes, if you have passive here, if you have passive setting here, then it's a problem. Everybody is ready to listen, but nobody is ready to send the messages, LACP message. And it means if both sides are passive, nobody is going to create this port channel. At least one side should be active, unless you are choosing the mode on. So I am writing it for you. What are the, although Punish will be showing you that how to bring up this port channel. The first thing first here, you need to decide that you are choosing LACP protocol. The second thing, you need to decide what are the different ports which should be part of this Ethernet, link aggregation control protocol or the port channel, right? Maybe you are deciding on 4. Third thing is which mode you are interested in. Or third thing, what should be the name which of this port channel which is combining these 4 interfaces? Maybe this is port channel PO1. Number 4, you need to decide whether LACP should run in active, passive, or on mode. On mode has a special requirement. If you have put on here and on here, then only this will come. That is it. If you have then active as a requirement, if you have active here, if that side is passive or active, the port channel will be up. If you have only passive, that side should be active, otherwise the port channel won't be up. If both are passive, it means that there is a problem, port channel won't come up. So you need to decide these 2 things, and you need to decide these 2 things on switch 1 as well as switch 2. The same things. Okay. Interesting. Right? So if I say before moving further, Mr. Punish or Rohit, do we have any question from anybody on this Ether channel?
So yes, Vishnu. So Harshit is asking, can we please explain again why active instead of on?
Why
If
active
I
instead
still
of?
have to
See,
manually configure the
yeah,
port channel.
this is basically again the rules which are written by the developers. Sometimes there is no why behind it, right? So they are saying that the LACP is written into 3 modes: active mode, right? And passive mode, and the third mode is on, right? For example, we are talking about switches now. This switch, right? So if you want to bundle some of the ports, then basically what we can do is I can do on here, I can do on here. This will become up and running. This is separate different mode. And why I can think it of that, why do have chosen this mode on, right? Because what if we are having a server here, and by the way guys, server has different NICs, right? Network interface card. Maybe it can have 4, which is again connected to this switch. And what you want to do is, now you want to do the port channel with the server. You can do that, believe me. But laptop, if I talk about laptop has only one interface, that there is no use of port channel. But yes, you are going to see in several data center network that you are going to make this port channel with the server, because you want that the server is having only 1 Gbps of traffic, 1 Gbps of NIC, then you want to combine 4 of its NICs to send the traffic of 4 Gbps, right? Interesting. Then between the switch and the server, this link should be combined. Then the problem is, guys, please be on mute. Moderators, please, can you take care of this? Can you put everybody on mute if you can? Except me, of course. So if you see here, we have the server. If you see here, we have the switch, and now we need a port channel between them. And server does not understand the complete LACP, right? It doesn't understand dynamic. It doesn't understand the meaning of passive. What we are going to do it? Because server could be anything from any brand, right? Although the LACP is standard, but I do not think that server is going to implement the full LACP. So they have decided to create a mode which everybody understands, which is on. So basically server runs in on mode, If you put here also on mode, then they are going to make this 4 interfaces as part of the port channel. It's a very, very good question, right? That why do we have come up with the on mode? But believe me, we want this to be automatically done in the case of switch. We do not want to configure much thing. We just want to tell LACP that I am interested in bundling these 4 ports. This is the name of my port channel, whatever is going to be. These are the ports, and I am running here active, which is and I don't care what is running here, right? If it is passive, it should be up and running. If it is active, it should be up and running, right? So it is going to automate your thing. That is it. I don't think any other reasons out of it, right? But you are more than welcome to just go around it. Just look at it, right? Having said that, do we have any other question, Mr. Rohit, regarding this?
There's one more.
Mhm.
So this is from Aman. So the question is, if both sides are active at the same time, won't it create a collision?
Okay, this is again interesting. So basically he's saying that we have switch 1, we have switch 2. Okay, tell me one thing, right? I have a counter question for you. Leave about these things, right? Leave about LACP. Why this question does not come to your mind that if we are having this host A, if we are having this host B, and we have only one interface between them, and if host A is sending something, at the same time host B is also sending sometime, do you think that there is going to be collision? Right? The question is good, but this wire which you are seeing here is the Ethernet wire. The question is not with respect to LACP or Ether channel. The question is right there in this wire. This wire is fully capable of doing duplex communication. Why? One in this direction, one in this direction at the same time, and that is known as a duplex one. And why it is able to do it? Because if you open this, there are 4 different cables, which we have talked about in our cable sections, right? We have talked about 1, 2 is for sending, 3, 6 is for receiving in case of the PC, right? Interesting. So we can send on 1, 2 from the PC, we can receive on 3, 6 on the PC, right? At the same time, and that is why there are 2 different pairs for sending as well as receiving. So this question should not be for the LACP. This question should be, doesn't matter if this is a single point, then whether they can send or receive. Right now, if I'm telling you that both are active, right? And if your question is more towards that the collision in terms of that, suppose if this guy is sending, I want to do port channel with you. If this guy is also sending, I want to do port channel with you, then both of them knows that there are 2, that we have other part also, which is in active mode. That is perfectly fine. And then it is saying that, okay, if you are doing that, then basically anybody can say that these are my number of ports. It is saying these are my number of ports, and these guys are going to make it, right? If your question is this is great. If your question is this is also great. Am I able to answer your question, Mr. Aman?
Yes, yes, sir.
Perfect. Perfect. And thank you so much for that. Thank you so much for asking the question. Guys, any do we have any other question? Rohit?
No more.
Perfect. Perfect. Okay. So the last topic of today is going to be an interesting. Yeah. Last topic of today is going to be layer 2 versus layer 3 ether channel. What is the meaning? But before that, I would like to tell you what is the meaning of layer 2 link versus layer 3 link, right? Interesting. And believe me, although in today's world, today's network engineer who are having experience of 2, 3, 4, 5, 6, 7 years, right? They use these terms very frequently. Oh, this is the layer 2 connection, this is the layer 3 connections. But believe me, whatever we are going to learn here Most of us have, most of us do not understand that, right? First thing first, let's talk about not the in terms of ether channel. I'm just talking about generally what is the meaning of layer 2 link, right? So suppose if we have this switch, and I have connected a host here, A, B, and then basically this is going to be my switch 1, this is going to be my switch 2. Please pay close attention. This is going to be very, very useful for you. A, B, I'm talking about first thing first, which is the layer 2 link, right? Right here, if you can see that if this guy sends a packet, maybe this is 192.168.10.0 or 10.10/24, this is .20/24, both are part of the same network. This is A.A.A MAC address, this is B.B.B MAC address. So if I send a message from here to here, definitely it is going to have IP packet, and top of IP packet is going to put the layer 2 frame, which is going to have the source address and destination address, which is A and B. This message is going to be received to switch 1. I'm not talking about ARP or everything. Presume that ARP is done, everything is done. This switch has a CAM table that if it wants to forward this packet towards B.B, it needs to forward it towards 0/2. We all know that, right? But try to think from switch 1 perspective. Does switch 1 care about the IP addressing? No, absolutely not, right? Why? Because it is going to see the destination MAC address and just going to put this frame here. It is as simple as that. It doesn't even care that whether an IP address is there or not. Interesting, right? All the links that share such property that they do not care about the IP address, they just forward on the basis of MAC address, are known as layer 2 link. So 0/1 interface of this switch is only dependent on the MAC address to forward the packet. That is why this interface is purely layer 2 interface. This interface 0/2, although it is a trunk interface, but it doesn't care about the IP address. This is going to be your layer 2. Similarly, this is layer 2, this is layer 2. If this guy is sending the reverse packet, of course, it is going to have the IP packet first. It is going to have the source and destination MAC addresses now, which is the destination is going to be A, and source is going to be B. This is source, this is destination. Here, this is source, this is destination. As simple as that. Again, when the packet is received over 0/1 interface of the switch, definitely it won't be seeing the IP address. It is forwarding the packet on the basis of this MAC address only. That's why this interface is layer 2. This interface is layer 2. As simple as that, right? But what is the meaning of layer 3 interface? What is the meaning of layer 3 interface? Just pay again close attention, right? Suppose I have, suppose now I have a router. Here we have a router, right? And I have an interface of this router, maybe 0/1, right? And I am connecting, maybe this is a switch, and maybe here we have a PC. Again, 5 more minutes, it is going to be very, very important. Of course, this router is also going to have the MAC address associated with this interfaces. Maybe it is say C.C.C. This is A.A.A MAC address. The IP address is suppose 192.168.10.10/24. This IP address is going to be the default gateway. So generally we choose the first address. Here the IP address is 192.168.10.1/24. Just try to understand now. This 0/1 interface is having the MAC address as well as the IP address. Interesting, right? But switch, here we do not need to define any IP address on this interface or this interface. Switch does not understand that, right? Again, the packet is going to be same. The packet will be that you are going to generate a packet which is having the IP1, and then you will be having the source MAC is going to be A.A.A. This is the source, and the destination is B, B, B. Sometime I reverse the rule destination source, but I will be writing from now onward. This is going to be my destination, not B, B, B. The destination is going to be C, C, C towards the router, right? This is the complete packet. Now switch, because these are two layer 2 interfaces. Why? They are going to send the packet on the basis of destination MAC address, but once it reaches here on the router's interface, again I'm drawing the packet once again, the IP packet. Sorry, first of all, this is CCC, this is the destination, A is the source, and the packet is inside it, which is the IP packet, right? Now, here is the interesting thing happen at the router level. Just try to understand. Router is going to think, right? Of course, if I am saying router is a layer 3 device, it is capable of understanding layer 3 means IP address. It is also capable of understanding layer 2 means MAC address. It is also capable of understanding L1 means whatever 10101s, right? But switch is capable of doing L2. It means that it can understand L2 means MAC. It can understand layer 1, the layer on which it works, and below layers, right? But here is the thing, when this router receives this packet, it is going to be towards the destination, which is C.C.C. Router is going to say, okay, right? This is my destination MAC address. This packet is for me, and that is why it is going to do one extra step. It is just not like switch. Router is not going to forward packet on the basis of MAC addresses. Through MAC addresses, it comes to know that, okay, this packet is for me. I am CCC, and that is the destination written on this packet, and that is why they are going to remove this our upper covering, right? If I give you another analogy from our post office, this was my envelope, and inside this envelope I have what? I have this IP packet. This envelope is right here with this IP packet, and on top of it we have this envelope, right? So I am fetching out this IP address first thing first. Why? Because in the red envelope the destination MAC address is written CCC, which is my address. It means that I am going to open it, and the process is known as decapsulation. Here I did was encapsulation. I inserted IP packet into the header, right? Here I am just removing this header from now here, and what I am remaining with the IP packet. And now I am going to check, because router understand the IP packet, and that is why they are going to see what is the destination IP address, and on the basis of that they are going to be forward. But what about this interface? This interface is capable of understanding the MAC address as well as IP address. That is why this is called as layer 3 interface. It is as simple as that. Layer 2 MAC addresses, and below that layer 3 IP addressing, and below that layer 3 means it is understanding IP address as well as MAC address. It is as simple as that, right? So if I may ask, what is the interface type of this one, which is the port of this host? Of course, this host has TCP IP layer implemented, right? It understands IP, it understands MAC. This is going to be your layer 3 port, no doubt about it, right? But on the switches, these are your layer 2 ports. It is as simple as that, because switch does not understand anything in IP. But on the router itself, this is again the layer 3 port. It is as simple as that. So if you create ether channel between two switches, those are going to be the layer 2 ether channel. It means that you are bundling layer 2 ports inside this, right? And whatever the port channel which we are coming, this is not going to understand the IP address. This is because you are combining two interfaces, the layer 2 interfaces. It is going to give you one interface, which is again the layer 2. It is as simple as that. But if you want to create the link between two, If you want to combine the link between two routers, you are going to combine them together. And previously you can assign the IP address here too. And now if you combine them, and it will become the layer 3 port channel, maybe the PO1, you can just go inside this interface PO1 and you can assign the IP address. Why? Because now it is the layer 3 port channel. It is as simple as that. So this is the difference between layer 2 versus layer 3. It is not in terms of ether channel, but basically the theory is this one, right? Now, if you have any doubt, any question, please do ask, because I am going to give this control now onwards to Mr. Punish, who is going to explain you. So Mr. Rohit, if we have a question here, we can answer it. Otherwise, we can go for the lab session. Mr. Rohit, Mr. Punish, do we have any question here?
No. No.
That is perfect. So although I had to start routing first, but we are again pretty slow with respect to understanding, but that is fine. I just wanted to tell you that we are not lost till yet. We are actually divided this problem, how to make two computers talk with each other, right? And believe me, we are just done with the data link layer. Layer 2 is done. From today onward, we are going to learn network layer, which is your layer 3. We are going to study some cool concept of dynamic routing protocol, which is OSPF. It is going to take one more session to complete this network layer for me, right? Once it is done, your CCNA syllabus, approximately 55% is going to be complete. Yes, we haven't even reached to 50% of the syllabus, but yes, we have 8 sessions done. Let's see how many sessions we're going to need more. But this is the time for Punish to showcase you whatever we have learned today on Packet Tracer. And if you are, one more thing, guys, on bridgewire.com, we are going to give you access maybe today, right? And whoever has registered till now and part of this course, maybe there are only 125 people which are part of this course. If you have registered on the Bridgewire, please try to register it today by before 6 or 7 p.m. And the reason is whoever has registered, I'm going to give the access for the CCNA, because from now on, the videos, specifically the hands-on videos, are going to be available on the bridgewire.com. That is it. Not anywhere else. Not on the YouTube, right? Having said that, Punish, it's all up to you. Please take the control and start the recording, right?
Thank you, Vishnu. Let me just start recording. I'll share